So, hello again everyone. Last time we saw how to print a hello world in NASM. Today we're going to see how to handle user input from the syscall read and how to do some arithmetic with it. Today we're going to see the instruction add to add a number. So, as we can see, we have the Linux system call table, and we have the sysread over here at area x0. So let's hop on our machine. And let's go to our file hello world.esm. Okay, so over here we have what we did last time. We have the hello world, we print the little hello world, and we have all the instructions for this is right, etc. So now we need to do the same thing but for the system read. Okay, so we begin by moving to area x, we move 0. This is the syscall for read. Okay, and we move to RDI the value 1. Okay, so to show you better, I got to show you what each file descriptor mean. So we have the standard input, it's 0, the standard output is 1, the standard error is 2. This is why in the system right we have 1 because this is the standard output, and in the system read we will have 0 because this is the standard input. So let's hop on, and now we need to move to RSI. In RSI, as we have in the Linux systable, we have a buffer. This buffer will contain the input. So let's create a buffer and let's call it input. Let's http://adb, and it will be 0. Okay, so right now we have this, and we put into db. We move to rdx, the length. This is the size because this is the count of how much the buffer will hold. So for the sake of simplicity, I will put at 10 bytes. So, and I will syscall. Okay, and syscall. Okay. Now we can go ahead and assemble our file NASM felf64 and hello world.esm. Okay, we link our file and we okay, so now we have our hello world, but we can input stuff over here. So if I input something, nothing will happen because we do nothing with the input. So let's open our file again. Okay, now let's do some arithmetic. Let's do an add. Okay, so if we go to the arithmetic instructions in x86 assembly, we have add, sub, and mul. This is the basics that we have. We also have more advanced one that we can cover later on. Okay, so first of all we need to create another value we call result. This is where we will store our result. So 0. This will be the result, and we need to before doing the arithmetic we need to store the input somewhere else. So we will store it in a register called EAL. So let's see a list of registers. Okay, so this is the list of registers in x86 and 64. So this is each register that we can use, and if we see in area X there is a 8-bit register called EAL. We will need to change our buffer, our input buffer to 8 byte or 10 byte. I don't remember how much 8-bit is, but I think we will be okay. Okay, so we'll move to EAL the input. So this symbol means that I'm referencing input, the memory address of input. I'm not cloning input, I'm just referencing memory address. So now let's add to all 1. Okay, and let's move back the value of all into result. Okay, so basically we can save, we can go ahead and NASM, we can LD or hello world.o and we can 8 out and 12. Nothing happened because we just add, but we don't print anything. So let's go ahead and print something. So let's just clear this and hello world.esm. Okay. So now the procedure is the same. We will just again move to x the value 1 for the syscall right. Syscall right. We move to RDI the handle. It will be 1. Oh, I made a mistake over here. It needs to be 0 because this is the standard input. Okay, and we move to RSI the result. We move to RDX the buffer length, the result length, and we will just allocate 10 bytes. Okay, and now we can syscall. Okay, so NASM FLF 6463 hello world.esm. We can go ahead and LT our hello world, and let's see. Okay, hello world 1, and we have a 2. This is it's over here. Okay, so now that we have this 2, we will look at something that it's not a bug, but it's something that is in assembly. It's a logic problem. So it's clear, and let's again. If I input a digit, a 2 value digit or more, it will just let me show you, and we will understand. So if I put 10, my result will be 2. Why? Because basically the system read system write, the buffer, the character buffer, is just a list in columns like this where we store our value. So for example, here we have the value 10. Okay, so when I do the add, he will go to the first position over here. I reference the first position, and this will do the add operation, and the others are not affected. So next time we will see how to do more complex arithmetic, and we will dive deeply into the concept of character arrays, and we will see how we can handle this type of operations. Because basically what we need to do is just to loop over all the array and add everything. Okay, so this is it for this lesson. Again, I'm not a professional assembler, not a professional assembly developer. I'm just a hobbyist. I'm learning assembly and teaching you what I learned, or trying to show what I learned. So if you have any questions, please comment. I will be happy to answer, and I will link all the resources in the description. Thank you.